It is a common experience that sometimes human beings are faced with some health challenges and are required to go to the hospital for treatment. But not so many people actually know the composition of the tablets or medicines or whatever items they are given for the treatment of their ailments. And that is why I'm going to talk about hydrogels this morning. These are biomaterials that have three-dimensional network structure. Their structure is as a result of the cross-linking or binding of the polymer chains that are used to formulate these hydrogels. Hydrogels have wide application in drug delivery, tissue engineering, also in wound dressing. However, because of the use of synthetic polymers in the formulation of these materials and even cross-linking agents that are synthetic, we often get materials that are toxic and not stable at different conditions. And because these materials are designed to interact with the body system when they are used, it is a fundamental requirement that they are completely biocompatible. And by this biocompatibility, I mean that they should be able to behave like the tissues of the body and not produce any adverse effects in the body. However, this is not the case. There are reports of issues of cytotoxicity, inflammatory responses, and some other issues when they are used in the body. Now, what is my solution in trying to break the wall of this non-biocompatibility in hydrogels? In my work, I have been able to formulate hydrogel systems that are completely biocompatible using an abundant resource in the South Pacific, that is coconuts, with the help of a non-pathogenic bacteria. Now, coconut in the South Pacific is in abundance and underutilized. What I tried to do was to use a bacteria to synthesize a material that is called bacterial cellulose. And in combination with another biopolymer that is also biocompatible called chitosan that is obtained from the shells of crabs and shrimps, I was able to come up with hydrogel systems that I was able to study their application in drug delivery and also in wound dressing. The first one you see there, I studied its application in wound dressing because of its stability, its antimicrobial action. It was also able to expedite the wound healing process when I did my study. In the second one, I was able to use it to look at the delivery of a drug that is called quetamine fumarate. This is used in the treatment of schizophrenia disease, dementia, and there are reports that in older adults, they skip dosages, like they're supposed to take 2 times a day, they forget to take and they take once. And because of this report, I studied the release of this, and it was able to offer me an extended release period. It means that rather than taking 2 or 3 times a day, they can just take once and do not worry about taking it again. Thank you.